Just have this here.
Great. Well, why don't we kick things off? Yeah, so hello, everybody. Hope everybody is doing super well today. Welcome to today's Handshake Tech Talk. So I'm super excited to have Daniel Tunkelang here to share with us some of his hard-earned insights on search. So as many of you know, this is a critical area for Handshake, whether it's students searching for the perfect job or employers looking for their ideal candidates. Search and relevance are really foundational to our marketplace. And Daniel's been a great partner to us for these last few months as he's engaged with Asif and myself and Andrew and a bunch of other folks across the company. As for Daniel, over his career, he's held full-time roles leading data science and search teams at places like Google and LinkedIn. And these days, he's an expert consultant who has helped some of the best companies in tech, such as Yelp and Salesforce, Zoom, eBay, Apple, just to name a few. And, you know, of course, Handshake too. So we're in pretty good company there. In today's talk, Daniel's going to break down how modern teams think about search and methods they use to increase search performance, relevance, and quality. So I'm sure we're all going to be able to learn a ton from him. And without further ado, I'll hand it off to him. Thanks, Daniel.
Thanks, Ed, for the kind intro. So this is an opinionated talk about what I think are not just things that are important in search, but I think areas that are that don't necessarily receive enough attention. And the 3 M's, as you'll see, are about metrics, models, and methods. And I'm going to talk about each of those. I'm happy to take questions or you know, any kind, particularly anything about clarification while I'm giving the talk, but I'll try to take well under the hour to make sure that we have ample time for Q&A at the end. And as you can see here, this is actually a presentation I originally prepared for the folks at Wikipedia last year, but thankfully search hasn't changed much since then. So let's start with the question of what search is, right? Because I think that many people think search is you type some things into a search box, you get a bunch of results back ranked, you click on one of them, hopefully the first one. And that's certainly part of what search is, but I think we have to think of search in first, not just as a technology or an implementation, but it's a process, and it's a process that involves people, right? Searchers have information-seeking goals. And before we started talking about search engines and information retrieval, there was an entire discipline of library and information science. You don't do the word library that much anymore, you know, in 2021. So these days, folks call themselves information scientists, but they think in terms of people who are looking for information and express their needs, try to achieve those goals, right? And we always have to remember that that's really what search is about, not the technology powering it. Now, of course, for building search engines, then we're translating what searchers have expressed in their queries into representations of intent. You can imagine there's like 2 levels of loss there, right? First, the searchers express their intent as queries, which isn't perfect. And then the search engine reverse engineers those queries back into the searcher intent. But this is a critical part of the process, without which you really can't do search. And then retrieve results relevant to that intent and rank them. So, and if you look here, you can kind of see the 3 pieces, right? Query understanding, retrieval, and ranking. Now, that communication process is pretty lossy, so it's important to think of it as being iterative. Searchers might change their queries, search engines can ask for clarification and so forth to support this ongoing process, this conversation. Now, searchers may use the search box for all of their search needs, but there are many different aspects to what search ends up being. So for example, if you're looking for a particular item, in our case, it might be, hey, I'm trying to look up a student or a company by name. That's what's called a known item search. You know what you're looking for. You probably end up entering something like a name or a primary key or some way of describing what you're looking for and expect that to show up. And this is where you see things like an autocomplete or type ahead interface, showing you that result and saying, aha, found it. Now, that's great. It's very different from exploratory search, where you might say, hey, I'm looking for tech companies that focus on healthcare, right? And then you'll know once you start looking at them if they match, but that's an exploration, it's a discovery. There is no one perfect result. You may very well use the same search box for both of those kinds of searches, but they're very different. And if you think about it, if you watched somebody doing a known item search, the happy path would be they type in a few characters, they see that result maybe in the autocomplete or certainly at the top or very close to the top of the search results. They click that one result and do whatever they're going to do when they're done. Well, an exploration might be you get a long list of results. You look at one, you look at another, you change your mind and so forth, right? So those search journeys are very different. Now, the other thing is that search, as somebody who works on search, I like to think search is, the most important thing in the world, but it's a means. People don't search for the sake of searching. They're trying to get information, trying to shop, to communicate, whatever it is. And so it's really important to look at search, to optimize it to measure it by, the way in which search helps users achieve that end. And that can sometimes get lost when people thinking about search focus on, did you click or did the machine learning model achieve some kind of metric in terms of its area under the curve or some other, kind of in the weeds of search, when really there is a user problem and perhaps an associated business goal that search is there to achieve. And that may seem obvious, but it's very easy to get lost in that because search itself offers a lot of opportunities to just think about search. And finally, search is kind of thankless, right? When search works, nobody says, oh, wow, search worked. That's so amazing. No, they take it for granted. And I've had my own 13-year-old daughter wonder, why is search so hard? And I realized it's a lot of work. It's like, no, explaining the challenges around indexing and query understanding and matching. But it's one of these things where you succeed if people are not complaining. And since you're never that good, people are always complaining. So I think anybody who's worked in search is familiar with this. For those who haven't worked in it, hopefully some of this will give a bit of insight into the things that make search as hard as it is to do right. So the most important decisions, right? These 3 M's: metrics, models, and methods. So metrics are what we measure and optimize for. Models are the way in which we represent the search experience so that we can simplify it enough to focus on it. And methods are the things that we do. And I'm going to give some examples in each of these buckets. So metrics, as Lord Kelvin said, to measure is to know. I think that gets lots of different translations, but the point is you got to measure stuff. So these, if I could only pick 3 things that I were measuring for search, they would be these 3. The first is binary relevance. And the word relevance is a bit overloaded, but here I don't mean do searchers get the best things or like the things, or in the case of e-commerce, buy the things that they find. I mean, are the results that they see relevant, yes or no? And there's room to debate whether relevance is binary. In fact, relevance almost certainly is not binary. There are degrees of relevance, but the notion of binary relevance is still useful. And I'll dive into that in a moment. The second is session success. Now, I'm using the word session specifically in search as distinct from query. When you come in to use a search engine, you do a search, maybe you click on a result and you're done. maybe you paginate, maybe you refine, maybe you do another search. All of that is part of the search journey. And the real question is, how often are those search journeys, those search sessions successful? It doesn't really matter, or it doesn't matter in the long run whether individual search queries are successful, because when it's like reading a story. If you think of the last book or story that you read, and I ask you how many pages was it, you probably don't remember. You can tell me the story because you'll remember the story, but at some level, you remember how it ended. You remember how you got there, but you don't necessarily think about those individual steps along the way. And it's that way with search sessions. What really matters is, does the search journey take people to where they're trying to go? And the third is search efficiency, because as much as I'm saying, does search take people to where they want to go, how much work it was is something that they'll remember. Hopefully reading the book, you don't think of the number of pages as how much work, but if it was difficult to read, you probably remember that if you kept having to, if it felt like effort. And search efficiency is something that we do think about, especially because search sometimes involves somewhat captive audiences who have no choice but to use the product, or maybe they do until they stop using it. So efficiency is a significant factor, not just their productivity, but also their happiness. So let's start with binary relevance. Mathematically, we're talking about essentially relevance getting a 1 or a 0. An information scientist in the 1960s said that relevance is a measure of information that relates a document to a query. That is, I take a query, I take a document that I can say, is the document relevant to the query? Now, he pointed out that that's necessary but not sufficient to determine relevance. And that's a good warning, because seeing a query does not necessarily tell us exactly what the searcher had in mind, right? This is a lossy process, but it's pretty good. So Goffman's warning notwithstanding, binary relevance posits the idea that we could take a query and a document and then say, is the document relevant to the query? And if you look at this diagram, there's this notion here of precision and recall. Precision being the fraction of documents returned that are relevant, recall being the fraction of relevant documents in the entire world or corpus that are relevant. And ideally, you would achieve perfect precision and recall by returning only the documents that are relevant. You're returning all of them, but typically you have a trade-off. Now, the interesting thing is that if I were to say, well, which of these two documents is more relevant? In many search cases, that's a very subjective question. However, I'm going to posit that very often you could say, well, I can tell you at least if something is not relevant. Now, it may seem like strange that there's this asymmetry, but bear with me with an example. If I ask Google to decide which of my emails are important, which it's happy to try to do with its priority inbox feature, I'm not persuaded. In fact, I don't trust that. I don't know if any of you use it, but I find this whole idea of telling me what's important to be a little bit fraught with uncertainty. But I trust Google's spam filter almost absolutely, because is this spam? Is this not at all relevant to me? Is a much easier question than saying, like, is this really important to me? So there is this asymmetry where you should be able to say, look, I know that's not relevant versus I know that is relevant. Like if I look for software engineering jobs and you say, well, is a software architect job more or less relevant than a software program manager job? Close calls or whatever. But if you tell me, hey, DoorDash is hiring drivers, like, no, I know that's not relevant. All right. So like there's that asymmetry is our friend here because we can measure non-relevance. And so, this is, I would say that if there's one thing you're going to measure, literally one thing, that it would be this binary relevance. Building a model, we'll get back to that in a moment of how to do that. Also, I mean, that measure of fraction of documents that are relevant. That's nice, but we return ranked list. So there's a positional bias inherent in search, and we want the top ranked things to be relevant. And you can do something as simple as like, hey, what fraction of the top 5 or top 10 are relevant? You can, there are various ways of weighing that, but the, you want a rank bias or position bias notion of how you're doing on relevance. And you want to stratify this for different query and user segments. If you have a whole variety of different sorts of queries, you don't want to be the averages that you use across all of your queries or all of your users to mask problems that are happening in subsets of those queries or users. And since you probably have some ways of either segmenting users or hopefully segmenting queries themselves, you can do this. So that's what I'm going to say about binary relevance. Now, the next thing is that let's talk about search sessions. So just like all heroes, searchers go on a searcher's journey. Apologies to Joseph Campbell. So search isn't always a one-shot journey, and it can't always be a one-shot. I mean, if I were to go back to my example of, I'm looking for software companies in healthcare, I don't just want to say, give me the top result and I'm done, right? I want to learn more. So I certainly learned, healthcare is lots of different things, or there are different sizes of companies, whatever it might be. So it's often the case that a search journey is inherently, it takes more than one step. Maybe sometimes it should take one step, and the search engine isn't perfect. But we have to think of this in terms of iterations. So as I said, we want to measure conversion or whatever success metric is at the session level, not at the query level. Now, what I recommend doing is saying, well, we want to group this by the first queries of sessions. Now, let me give an example. Like if I were to say that my first query, let's say, was healthcare, because I'm looking for companies in healthcare, or my query was Java engineer, because I'm trying to hire people who know Java. The assumption that I'm going to make here is that initial expression of intent is a meaningful thing to group by, and that the rest of the session is essentially elaborating on that. Because what I have in mind here is not just in general measuring session success for everyone, but being able to say, let's look at the sessions that begin with a common intent, and that way we can learn where we're doing well or doing badly, recognizing that a query is really a distribution of intents, not a single one. Now, defining a session can be tricky, and there's a lot of effort to say, can we break up someone's interaction with the search engine into a sequence of tasks and see when their task changes. It's a fascinating topic, but I think it's at the margins. I think it's simple enough to assume that when people come to a search engine, they had one thing in mind. They try to do it, they leave. Maybe they try to do multiple things. Hopefully those multiple things are random enough to treat as noise. But I would encourage, basically think of the session as coming in with intent, and at the end you either satisfy that intent or didn't, as a reasonable approximation.
May I ask a question?
Absolutely.
Hi. So in my experience, at least like with handshake search sessions, the first query isn't really the expression of intent, because people are building up a query, and some of this is just a technical point, right? You add filters and everything. In that case, is there a recommendation for how I've actually been looking at either the last query, or in the case of keywords, the longest strings. Is there another recommendation for something like that, where the queries sort of come in, they're sort of built up gradually?
Well, in the extreme case, let's say that whereas you type, your search is populated as you type, clearly you don't want to take all the sort of prefixes that you get there. But I'd say that it really depends on why your initial query versus what you're thinking of, in this case is your final query, where that gap is. If most people are, they're lazy enough, they didn't set out to do multiple queries. So their first query is often what they meant. And then the subsequent queries are, you stupid search engine, why don't you understand me? I have to add more, I have to take away more. But people, in those many times, people believe that, they said what they wanted the first time. If the interface doesn't encourage that, the first thing I would ask is, can we get there? But my experience is that refined queries are already reflecting a sort of a back and forth with the search engine. They're not as sort of pure an expression. So I mean, that's something we should dive into. But normally, there's actually a lot of bias in the subsequent queries. Like, for example, if you're suggested refinements, of course, you're going to use refinements suggested to you because they're right in front of you versus things that you had in mind.
Right. I mean, I guess that makes sense, considering like even before you do filters and things, we're trying to personalize your results. The more you have to put in additional, adjustments to that, you can argue that's, not ideal. So yeah, I can buy that.
Yeah. I mean, look, more signal from the user is better, but usually the most signal you get is upfront. I mean, and by the way, I know we have this unusual thing that so many people don't even bother to fill the search box. Although, to be fair, that's in part because we're, if we deliver recommendations, their search is really, I want the job. And we said, we know what kind of job you want, and here you go. And in fact, if we do a good, if we do our part right, that's effectively the search. It's a keywordless search that just by virtue of coming to the site, you would, sort of know. So that, I mean, that's tricky here. I am focused on the cases where the assumption is that you do need a little bit more signal to do something meaningful, and usually it is that first search.
Cool, thanks.
Okay, but let's, we talked about journeys, but let's talk a bit about search efficiency, right? So in general, less work is better. And my favorite professor in college told me, learning is not fun. Having learned is fun, which is always a great way to start a class. But he had a point, right? Like people don't search because they enjoy searching. They search because they want to find something, and then they're like, "That was great." And usually, if search is too much work, people will give up. So, you certainly want to measure how much time it takes or how many steps it takes for people to search. And every way of measuring this is a little bit tricky. And I actually recommend, kind of measuring all of them until you find something that works best, right? You can measure the total number of search events, most of which will probably be pagination of search in a session. Reformulation, where people actually type in another search. That's a huge effort for people to make. They usually don't like it. Refinement is easier, but it's still steps. Now, the other thing is that in general, if you think about this, when you're searching for stuff, your goal is the stuff, not the searching. So looking at the ratio of time you spend getting to the results versus on the results can be useful, with a caution that this assumes that the results are kind of really rich in the signal that you want. I've seen cases where the result is a 100-page document and you probably just want one line on it. So effectively, looking at the document is search, except that you're using, Command or Control F instead of, or scanning it. But that aside, right, you want to basically get a sense of the time people are consuming the fruits of their labors rather than actually investing those labors. But the other thing is that if you have a notion of session success, and in e-commerce that might be conversion, in say Handshake's case it might be applying for a job or contacting the student, then you can look at successful and unsuccessful sessions. And what I've observed is the following: that with successful sessions, you get to the end of the journey quickly, and then it either succeeds or fails. While with, there's journeys that are easy, in which case either like they succeed or they don't succeed, but you've gotten there quickly. While for a different category where the kind of search is making it too difficult, the successful ones take a long time. The unsuccessful ones drop off much sooner. And that can give you a sense as to whether you have friction that's part of the problem. And because, I mean, the success of search, if you tie that to, did you find what you wanted? Well, there are two separate questions, right? Like, if we don't have what you want, you're not going to be happy, but at least let's get you there faster rather than slower. If we do have what you want, then if we take too long to find it for you, you might give up anyway. So that's the case where we want to be conscious of requiring too much effort to get you to a positive outcome that we could have gotten you to. So binary relevance, session success, and search efficiency, and I'll keep moving because I know I'm taking way longer in the section than I should have. So let's talk a bit about models. Models simplify the world. They're all inaccurate in one way or another, but they can be useful. So there are three things I think are worth modeling. Binary relevance I've referred to already, but the other are the notions of categorizing queries and measuring the similarity of queries. And these are things, the first two that I've seen, the first one I've seen a lot of attention to lately, the second one very little. So I want to talk about this a bit. The first is categorizing queries. The old-fashioned search, and to be candid, some of Handshake search today basically says we're going to just treat search as a bunch of words and retrieve the things with those. Like, we immediately jump to saying, let's find documents and score them. Now, ideally, search starts with an earlier step that says, wait, what does the query mean? Let's actually focus on getting an intent out of that query. And the simplest notion of intent is a classification of the query into some kind of taxonomy. In e-commerce, that would typically be, what kind of product are you getting? If you're looking for, in a research library, it would be the topic or the subject. There can be a variety of ways in which you have this. And to be fair, in Handshake's case, this is a little bit trickier than others because people and companies don't necessarily categorize as well and might have to think about different notions of intent here. But it's sort of a high-level intent. I mean, a different way of looking at this is saying, oh, does it look like you're looking for a company name? Does it look like you're looking for an industry or something else? But getting a high-level understanding of a bucket to put the query in. And whatever this categorization scheme is, the categories should be reasonably coherent, distinct from one another, and useful. And to be fair, any kind of categorization requires good categories as a starting point. But if we do that, then, and in particular if our content is already categorized, it's really easy to train a categorization model. For example, if you have 1,000 queries that are your head queries, you just label them by hand. Get some pizza or junk food of your choice, and get enough people, and now you have 1,000 queries with labels. And by the way, for some people, that's like that might already be 20% of your search traffic, which is nothing to sneeze at. Now, as you go further down the distribution, you could say, oh well, I'll look at the categories people engaged with when they performed these queries. And hopefully, in most cases, there's a dominant one or a handful of dominant ones. And I'll be able to say, great, those must be the categories for those queries. There's some presentation bias there because people could only engage with the stuff that they found. That's going to be a problem for any kind of really machine learning approach, unfortunately. But this one, this isn't even machine learning. This is literally just counting. Now, hopefully, if you've gotten this far, you have a decent set of queries that you have labeled either by hand, if they're small, or by some simple analytics. And this maybe even got you to 10,000, 100,000 queries. Now, you can treat those as labeled data, labeled queries, and actually train a machine learning model. And this training data is biased in an important way because it's going to be your more frequent queries, and you're going to be applying it to your less frequent queries. But here's a dirty secret of search. Your less frequent queries look a lot like your more frequent queries. All right, it's healthcare and then like healthcare small company. Right? It's healthcare and then healthcare without the space. Right, there are a lot of your less frequent queries are relatively small variations of the more frequent queries, often by just adding another word or changing an ending or that sort of thing. And a lot of the off-the-shelf models designed for classifying text work extremely well with that. I'm a big fan of fast text, which I think is now getting close to a decade old, for as in the Facebook AI research group released this open source a while ago with pre-trained models, no less. So I found that you can get quite far with an approach like this for query categorization. So let's talk a bit about query similarity. And I love kittens, so I had to. Now, earlier I said like there's the user's intent, the searcher's intent, and then there's the searcher's query. And many people worry about the case where, oh, I have this query, but maybe it means two different things. Like, I mean, Java, do you mean the place in Indonesia, or do you mean the programming language, or do you mean coffee? That's great for teaching a class in information retrieval. It's actually not very common in real life to get that kind of ambiguity in queries. So you have to, people keep recycling a handful of examples. What's actually more interesting is that people will express the same intent in different ways, right? They'll say a cup of coffee, a coffee cup, a cup with coffee, coffee by itself, right? You can imagine all the variations. There are such obvious variations, you don't think twice about them. But the most search stacks do not take into account that multiple queries mean the same thing. Maybe they do some stemming. They'll say singular and plural versions of a word get sort of turned into a canonical form, but that's about the extent of it. Maybe they drop a word like the or and, although often they don't. And to be fair, for some reasons, because sometimes those words will matter. If you're Franklin and Marshall College, you probably care about your and. But but basically, there's a lot of opportunity to recognize that multiple queries mean the same thing, so that you direct them to the same kind of experience, right? If one of these queries does better than the other, then everybody should benefit from the better version of the query if it's the same intent. If you're learning, if you're collecting signals about how this query does, you should be collecting for that intent, not fragmenting it across all of these queries. And I can tell you from work I've done elsewhere that capturing this is a huge opportunity to improve the performance of search, because inevitably there is a lot of variability in processing what any user looking at it would say is the same intent. So how do you model query similarity? First off, you can do simple things like say, well, if we did that stemming for singular and plural, if we maybe ignored word order, and in particularly languages that have diacritics like German, if we were a little bit relaxed about accents or other marks, and I'll be fair, to be fair, outside of Romance and Germanic languages, I'm not sure how well that applies, but we can basically start saying, hey, can we see, do these queries look the same? Or maybe there's only, two queries, one's probably spelling error the other because they only differ by one character. So those kinds of ways of looking if queries are similar get you pretty far. They will have, you have to watch out for queries that look similar but are very different. But now we get to the other way you can look at queries, which is to say, let's look at the results that these queries return and compare them. And you'd expect that queries that mean the same things tend to return results that mean the same things. And when you're training with queries that are at least reasonable queries, you can do this. And then you can effectively use this to complement looking at the queries themselves, right? Ideally, you'd say, these queries look pretty similar, and these results look pretty similar. That's great. They probably have, that's a good sign that they have shared intent. But if there's a big variation, you could say, okay, well, I thought that dress shirt and shirt dress, I'm just changing the order. Is it really different? Oh wow, it really is different. Or maybe if I had done my query categorization, they would have taken me to different categories. But you want to basically protect yourself from situations like that. And one way to do that is to look at the results. And I snuck embeddings in here, but again, not necessarily fancy use of the latest and greatest in AI, but a word embedding like fast text, again, get you quite far. And finally, I mentioned binary relevance, this is the simplest question as to whether results are or not relevant. And by the way, relevance of a result assumes that you actually know what the query means. So let's pretend that actually the query itself has done its job of representing that intent. And again, that relevance, we're treating it as objective. Then you can train a relevance model by collecting binary judgments. And quantity matters more than quality this, because we're not aiming for, you don't want systematic errors, but we're not aiming for perfect agreement on the hardest relevance judgments. The goal here is just to see, are we, we're hoping for what should be a relatively simple binary question. And collecting judgments like this allows you to train a binary relevance model that can be essentially the first order bit in ranking. So these are the three things I would model. I finally want to talk a bit about methods. So three things that I found to be useful tricks, and the second two I've already kind of alluded to earlier, are optimizing for query performance, relating tail queries to kind of head intents, and focusing on successful sessions. So what do I mean by query performance? Basically, if you do a query, will we make you happy? And this is not, is this result good? This is, when you type in a query, what is our prediction of our ability to get you to a happy outcome for this query or for the journey? I like session success here. This is not usually the view people take, or what they're focusing on. Like, no, it's not our job to return the best results. But what if you could actually influence the query before they did it? So that as you're typing in a query, you're about to type in, so an example, I do like e-commerce examples, that you start typing in jeans, J-E-A, and I could take you to jeans, but I don't know what kinds of jeans you want. There's a huge variety of jeans, and whether it's gender, age, material, color, whatever the various attributes people might have in mind, jeans is a really broad query. And if you look at specifically at Amazon, you'll see that with clothing queries, they encourage you to at least get another word or two in there before you hit enter. And there's a good reason for that, which is that we're not, like, if you have a query as broad as jeans or shoes, the likelihood that the top results are going to be what you want is extremely low. Just don't know enough. We need more signal from you. So in something like autocomplete or search suggestions, refinements, right? Like that, there's an opportunity to think about the predicted performance for the query. And that's something that we can optimize. Now, often with queries, we've seen them before. So we know how they do, right? We know if we see this query a million times, like, this query converted at 5%, this query converted 20%. Be nice to get the 20% one. Why is that 5% query happening? Maybe because it's short. Maybe it's because we push it to people. But we should nudge people towards better performing queries. If we've seen the queries before, we can actually just, we don't need to do any prediction. We know how they've done historically. if we haven't seen the queries before, there are a lot of ways we can try to analyze either before the query is done or after the query is done, whether these results hold together well, whether the query holds together well. And this is, I mean, not expecting anyone to sort of look at all of these methods. These are basically what you do when you don't have data. And they're variations on saying, are the results self-similar, or are they very sensitive to slight changes in the process? All these perturbation methods are inspired by work in physics. Honestly, the historical ones are better, of course, if you have the data to do it. But whatever your method, whenever you have a surface for suggesting queries, this is an opportunity to nudge people towards better queries. So use it. Don't just, don't just direct people towards the most popular queries. Consider the ones that will that are likely to do better. And if you're basically have two queries that look similar, you have the ability to nudge people towards hopefully an equivalent intent but higher performing query. And finally, the notion of tail queries. It's funny because when people think about the distribution of what people do in search, they think, oh, these are the most frequent queries, less frequent, and so forth. But what's not, queries are expressions of intent. And my observation has been that intents are actually more concentrated than queries. So even when people say a tail query, like maybe just a misspelling of a head query, or maybe people normally look for the query in the singular, but sometimes in the plural, or they change the word order. And so there's a huge opportunity here to say, look, this may be a tail query, but it actually looks a lot like a head query I've seen before. And and using this kind of query similarity approach I proposed earlier, there's an opportunity there to nudge people towards from the tail to head. So, if you see a query that you're not familiar with, consider, hey, maybe this is a misspelling of a head query. And don't worry about where the spaces are. Be more aggressive, because the head queries are more likely. And so, you can basically try harder to go on the prior that the intent of the user is a frequent intent, even if you haven't seen that query before. But of course, try to measure the potential drift in intent. And finally, learn from the successful journeys of users. So, there are queries that everybody does well on, and there are some queries where some users do well, but others don't. Often because those users they're more sophisticated searchers, they're more determined, persistent, and so forth. So let the successful users discover those paths and then learn from those paths to optimize the ones that the other ones didn't find. So for example, if we see searches where the successful searches are long, what did those searchers do that took so long? Did they refine the category? Did they reformulate the queries? Well, that's great they figured that out, but we can build in shortcuts. We can have those refinements on the top line as suggested refinements. We could have related searches right at the top, or maybe we should even think about changing the query in the first place. But we can effectively treat those trails as opportunities for shortcuts and prioritize those in the experience. So, optimize for query performance, try to map things to head intents, and learn from successful sessions. So putting it all together, right? These are all sorts of metrics, models, and methods. Remember that query understanding has to come before you think about the relevance of results to the query. Think about the relevance in a binary way first before worrying about things like ranking. Up level from thinking about how queries do to how the whole session do, and really just try to get the leverage you can from head queries. And with that, I'm open to questions. And of course, you hardly need to use my Gmail. I'm always here on Slack as well.